Are there any questions? All right, so we just found the value of A. Let's go ahead and use determinants to find the value of B. Well, I know my denominator is going to be the same thing as it was before, but just as a refresher, I'm taking the coefficients of the variables over there. So I have 1, -3, 0, -1, -4, 4, -1, 0, -6. And I get, what was the denominator for A? 54? All right, my numerator, since B is the middle variable over there, I will put in my constants in for that row, or column. So I have 1, -3, 0, -1, 0, 6. So those remain the same as the denominator, and then I put in a 0, -8, 12. What I'm going to do is I'm just going to rewrite the first two columns, or sorry, yeah, the first two columns again. 3, 0, 0. So I multiply that diagonal. -48. That diagonal plus 0. That diagonal plus 36. Minus that diagonal, 0. That diagonal, 0. That diagonal, 0. I think I can handle that. So I end up with -12 over 54, which is something. What is that as a decimal?
Would most, I know that one was pretty simple with all the zeros. Would that, is it usually have a bunch of zeros, or is that just how that?
Yeah, usually.
Okay.
Because you're gonna have a 0 over here every time. And when you do the loops, if I do the left loop, there's no C. If I do the right loop, there is no A. If I did the overall thing, the outside, there'd be no B, so you're gonna end up with a 0 in 2 of the spots here. So at some point, you quite possibly will have 3 zeros.
That's 0.222 repeating, or negative.
-0.2 repeating.
I have a question. What did we get for the value of A?
Where?
Value of A.
Where did we get it? We didn't.
What is it?
What is it?
The 54.
What was it?
54.
54? That wasn't all of it.
32 or
32 over 54? Which is, what is a decimal?
.5925.
Amperes. And, oh, I did not write units over here. All right, so across resistor 1, which was up here, it is 0.5925 amperes to the right. Cross resistor 2, 0.5925 amperes to the left. We just found B, so R4 is negative 0.22 repeating, going down. Or you could say 0.22 amperes going up. So it's negative down or positive up. Some students will write the negative 0.22 and then go, oh, that means it's going up, and then write up over here. No, you change them both, or you don't change either of them.
Wait, why is it negative?
Because we got a negative over there.
Oh.
And it's down because I said B was down. So it's 4, positive 0.22 amperes upwards. And so now we need to find C. Now, there's a simpler way of finding C than what I'm about to do, but I'm going to do it anyway, the harder way. Any questions up to here before we find C? All right, let's find C. That's the one. Well, I know my denominator is 54. My numerator. Since I'm trying to find the third column over there, or the third variable, the first two are the same as before. 1, negative 3, 0, negative 1, negative 4, 4. And now 0, negative 8, 12. I'm going to do the 3 by 3 determinant sort of wrapping around as opposed to writing the first two columns again, which in essence is what I'm doing here. But so I've got negative 48. And then I've got 0. And then I've got 0 minus 0 plus, that is a negative, yeah. Negative 1 times negative 3 times 12, which is 36, plus 1, negative 8, 4, negative 32.
So, was that different from just writing the first two columns on the right and just doing the same thing?
No, it's not different.
You just did, right?
Yeah. Because if I wrote the first column over again, I'd have negative 1 times negative 8 minus this, which is just 0. All right, so I have negative 48 minus 4, so I had negative 44.
Wait, wouldn't it be negative 52?
Yes? Will we do correct math? Thank you. And as a decimal?
0.9629 for negative, yeah.
All right. Now let's actually see if we've made a mistake somewhere. So that was negative 9629, negative 0.9629 going to the right. Now, given our equations over there were based upon our assumptions over here. So I'm just going to plug these numbers in to see if it still works. So A was 0.5925, B was negative 0.22 repeating, and C was negative 0.9629. There's a mistake somewhere. It's one of those frustrating things about these problems. So, the question is there a problem with our equations? Is there a problem with the math we did after that? And, it's really hard to tell right now. Well, let's first check our equations. I have A coming into this junction here. I have B and C coming out. So the current in equals the current out. I did the right loop, so I have 3 minus A minus 4B plus 5 minus 2A. And then I did the right loop going in the direction of current, so I have -7 minus 5 plus 4B, because I'm going against current, minus 6C equals 0. So the equations look fine.
Where did we get the 54 in the denominator?
I did the determinant of the coefficients. So the denominator is going to be just 1, -3, 0, -1, -4, 4, -1, 0, -6, just looking at the numbers
Yeah.
in front. And imply 1 where you don't see a number. So, well, as we're checking this, those seem okay. These, so I got everything over, so I had A minus B minus C equals 0, so that checks. This one, I have 3 and 5. I took that to the right side, so it's -8. Then I have -3A minus 4B, and then 0C. And then I've got -12 here, add that over. I have no A's, 4 B's, -6 C's equals 12, so those are looking fine. So there's a mistake with the determinants. So let's check out the denominator. 1, -3, 0, -1, -4, 4. That's 24. Plus 0, plus 12, minus 0, 0, -18. So 36 minus -18, 54. The marker's probably not gonna work on this board. Actually, the marker will work on the board, it's just not the way it's meant to be used. So denominator here, our numerator, 1, -3, 0, -1, -4, 4, -1, 0, -6. One of the reasons why we solve for C using the determinant, one is again to expose you to the determinants more, but also if I use this equation, I could not have used this equation to check my answer. So I used determinant still so I could check, and it did not work out.
Wait, which, is this for A?
This is C right here. No, actually, this is my determinants again, so, or my denominator. That one. That one. So 0, -8, 12. So I got 1, -3, 0, -1, -4, 4, then 0, -8, 12. Okay, repeated those. Those look the same. So my positive diagonal. So I multiply those, I get negative 48. I multiply those, I get 0. I multiply those, I get 0. Minus, going the other direction. 0. Negative 48. Well, that's different. No, that's not, because that's not right.
It's 32,
It is 32.
which is still different.
Plus 36.
This is backwards.
Yeah. So that's 4. That's negative 48. So we get that. So C is looking good. Questions?
Why did we make, so 38 or 36 at the end is, negative? Right?
36 at the end, we got that from negative 1 times negative 3 times 12.
So how did we get 4 out of that?
Because I have negative 32 plus 36.
Oh, negative, okay.
Other questions? All right, let's check B. So the numerator should be 1, negative 3, 0, 0, negative 8, 12, negative 1, 0, negative 6. Eight times 6 is 48. Ah, there's the problem. That should be at negative 6. 1 minus sign. It's a lot of fun grading these too. Plus 0, plus the 0, plus 36, minus, and then we'll get 0. $84. All right, what's B?
1.555.
1.5 repeating.
Mine has a 6 at the end, but that
Okay.
should be right.
Amperes going, that's positive over there, so we're going down. All right, so B, 1.555. And is 1.555 minus 0.9629 equal close enough to this? We gotta check. It feels good when that works.
We determined the direction by the sign.
Yeah, we determine the direction because I start out with the current's flowing in some particular direction. If I get a positive sign, well, then I can just go with whatever I solve for mathematically, I just put the direction in whatever direction I established to begin with. Or I could, for instance, this one, I could just flip the arrow and change the sign.
Is it 0.55 repeated?
Yeah. I got 0.9625, so we're 0.0004.
Okay. And some students prefer the fraction, especially if you're using determinants, the fraction's right there. and you don't have to reduce the fraction. Oh, and the voltage going across the 4 ohm resistor. Well, I know the current, I know the resistance,
Multiply that.
and if you multiply them, what do you get?
Oh, volts.
In the direction?
Down.
Yeah.
Is it up?
Remember, when you're going with the current, you're losing potential.
Yeah.
And since our current is flowing this way, we're losing potential going across it,
But,
or gaining going up it.
oh, because we are at positive voltage, it's gonna be up.
Yes.
it was
Because
like-
you told me a positive volt.
Yeah.
Or that's down and that's negative. And I've had students go through all of this and get everything correct except for the sign at the very end. No credit.
Is this chapter 20 or 21?
Yes. 21.
So this won't be on our quiz Wednesday?
No. It'll be on the following quiz. All right, we have answers now. Feeling good. We could check one more if we wanted to, but I'm feeling good. So we're gonna solve it again, differently. Yeah.
This is just like the rental problems.
Yes, there is a similarity to it. All right, the equation is just the math bit. We're not gonna use determinants. Then at some point, I'm gonna show you what's called mesh analysis, which is a different style of doing this. Instead of doing the one current per branch, it's one current per loop. And it has some advantages, and, no, we'll get there.